Hi, everybody. My name is Mohammed Gassimi. It's my pleasure to welcome you to CSE 491 this semester at Michigan State University. If you're joining us on campus, welcome. Glad to have you in East Lansing. If you're not at Michigan State University and you're watching this, also want to welcome you. If you like the content that you observe in this class to help it get boosted by YouTube's algorithm, I'd appreciate it if you like or subscribe. So what are we covering in this class? Well, there's a lot happening in AI. There's been a lot happening, especially since ChatGPT's debut in November 2022. Billions of dollars invested, some billion-dollar job offers in large tech companies, and a lot more exciting things. And so naturally, one thing you might be wondering is, what's the future of AI going to look like? Well, we've been through four major eras: rules-based, machine learning, deep learning, and most recently, the generative AI era that we've all become so familiar with. The future of artificial intelligence is agentic. It's not an opinion of mine. That's what many people in the field believe. So what does it mean to be agentic? Well, pretty simply, agentic AI is an orchestration of the various subcomponents of AI, as well as some classical system things, databases, web search, and so on. As we go through this class, my main objective for you is to, one, understand what these AI agent systems are, but two, more importantly, I want you to be able to leave the class being able to build them for your personal projects, for job interviews you might do as part of a capstone if you're still a student by the time that you're done with this class. That's really our objective here. In order to help us accomplish that, the whole course is built around project-based activities. I'll be giving you a template of an AI-based web application, and over the course of the semester, we'll be increasingly augmenting that AI web application so it can do more and more agentic tasks. Really glad to have you here this semester. Please feel free to reach out to me anytime if you have questions. Okay, everybody, let's jump straight into the first lecture of this semester on AI agents. We're going to be covering three topics today. The first is we want to define what AI is. That's going to be pretty important, right, if we want to do the second point in this lecture about what an AI agent is and how that's similar and different from agentic AI. Lastly, we're going to be covering the specific approach that we'll be using in this class to learn about AI agents and why we'll be using that approach. So first topic, what is AI? Well, at its simplest, AI is any tool that allows us to mimic a human capability. What you can see here is a timeline that I've drawn starting in the 1950s, spanning all the way to the present era. What you'll notice is there's these four colored boxes: rules-based systems, machine learning, deep learning, and generative AI. What these represent are approximately the four kind of major thrusts that we've had in the development of AI systems from the 50s onward, starting with rules-based systems, moving into machine learning, into deep learning, and finally culminating in generative AI systems that we all know and love. Your ChatGPTs, your Claude codes, and so on. So what I'd like to do is give you an intuition for these four eras of artificial intelligence. And the way I'd like to do that is through an analogy. You'll come to know, if you get to know me, I love analogies. So the analogy I'm going to choose is actually IKEA. But before I jump into that analogy, I want you to note that a rules-based system has some things that a human provides and some things that a machine provides. Human gives the task, gives the data, gives the tools, and gives the approach, and a machine provides the execution. So what is this in the IKEA analogy? Well, the task in the IKEA analogy is what you want to build, right? Let's say you go to IKEA, you're moving into a new apartment, and you want to get yourself this gorgeous bed. Well, here you are, the hypothetical you having a great time building that IKEA furniture. And the data in this analogy is like the wooden blocks that you receive in the kit. The tools are those little Allen wrenches that bruise your knuckles. And the approach is the hieroglyphics, which we know as the instruction manual that comes in the kit. Now, of course, if we're talking about AI, this is an analogy. So AI is playing the role of you in a rules-based system, and IKEA is playing the role of the human. You're providing it with the data, the tools, the approach, and the task, and then, in this case, this AI goes off and builds the furniture because you've provided everything it needs. Okay, if we shift to the machine learning era, what you notice is different between these two eras is that the approach here ended up moving from something humans provide to something that machines provide down here. Okay, in our analogy, what does that mean? That means we get rid of the approach. The instruction manual was not provided in this kit. We just dumped the data, which is the wooden blocks, and those horrible Allen wrenches on our machine worker and said, go build me the beautiful bed. Okay, this might surprise the machine, but hey, machines are getting smarter, so we can be a little bit more vague and less instructive in our approaches is the idea. As we move from the machine learning to the deep learning era, what you'll notice between these two is that, again, the last item on the list here, the tooling, ended up being moved from something that humans provide to something that machines provide. Okay? Back to our analogy, what would that be? Well, that means we got rid of the tools here. Okay? The Allen wrench is no longer provided. We just give the wooden blocks and we assume that the machine will be able to bring its own tooling to figure out how to assemble those. And not only that, we'll be able to determine the approach to use to put the furniture together. Okay, finally, as we move from the deep learning to the generative AI era, you might notice that that item data here moved off the list and again entered what the machines provide. And so the equivalent of this would be us striking all of the inputs that we provide. There's no longer any wooden blocks that are given. We just provide the instructions that, hey, I want a bed, and we expect that the machine will provide that to us by figuring out what data it needs, which are the wooden blocks, what tools it will need, the little Allen wrench, what approach it will need, i.e. the instructions, in order to get us that end product. If this were a human, we'd be obviously very upset, but machines obviously don't have the same issues that we have with building IKEA furniture, so I think a machine would be as happy doing this as any other task. Okay, so these are the four eras of AI. Now, I wanted to make this clear because all of AI has been culminating in systems that require us to provide less information and get the same output. What you may have noticed as we moved from rules-based system to machine learning, from machine learning to deep learning, and from deep learning finally to the generative AI era, was kept striking items off the list. We want to give less and get more. Agentic AI is the next natural step in that evolutionary process, and it's grounded in real issues that generative AI systems have, many of which you're probably familiar with if you've used AI systems or generative AI systems, and if you haven't, you really should go check those out. You're about 3 years late to the game. Okay, so let's talk about what the limitations are, because if you don't understand what's challenging about generative AI today, you won't understand why there's an interest in AI agents and agentic AI. First problem, generative AI is limited by its pre-training. So you probably are aware that large language models developed by Google, OpenAI, Meta, and so on take these giant corpora, text from the internet, images from the internet. Some of that comes from their closed ecosystems, but they use those to train machines how to answer questions that are relevant to those data sets. The issue is, of course, not all data, not all knowledge, maybe more generally, is publicly available. And even if it is publicly available, it may not have been fully or properly ingested into these AIs that are available today. Okay, one example of that is documents that are classified by the US government. It's estimated this is some 50 million documents a year that LLMs are not going to be able to reliably answer questions about. This doesn't include all of the documents that discuss trade secrets in the context of companies or strategies that businesses might use to beat their competitors and so on. So none of this is to diminish, of course, the incredible value that AI and LLMs bring, but it is to say that they don't know everything, right? Because they can't see everything. Now, even if they could see everything, they still wouldn't be able to answer everything. There is a phenomena which I'm very sure if you've played with an LLM you're aware of, that's called hallucination, which is an LLM making a mistake even if it had relevant context within its training data set. Common example of this is large language models making up citations or misattributing citations to text that they generate. I have one particularly funny example here where Google, in one of its earlier AI renditions, reported that there was a 2018 study published in BMJ that found parachutes are no more effective than backpacks at preventing death or major injuries when you jump out of an aircraft. So I don't know about you. I'd like to see and read that paper myself to sort of understand their methodology, but this is an example of the kinds of hallucinations that you can get. Why? Because generative AI systems are not trained to memorize all the text that they read on the internet. It may have read several BMJ studies in its training data, but having read those studies does not guarantee that it can word for word regenerate them, because it learned an abstract representation across all the texts that it read, not a memorization of every text that it read. Okay? So hallucination is the second issue that these LLMs have. The third issue is that generative AI systems, there are performance differences depending on which one you're using. So if you've used Claude Code as an example versus OpenAI, you might notice for certain coding tasks there are differences in the performance. What I'm showing you here in the table on the left are three LLMs, Claude 3.5, Claude 3, and GPT-4o, and I'm showing you a couple of tasks. This is graduate level reasoning tasks, undergraduate knowledge tasks that are embedded in a benchmark called MMLU, a coding task, and a math problem-solving task. And what you can see here is that the model that did best on these tasks is represented based on the green that shows up. So in this case, Claude 3.5 did the best on graduate-level reasoning, did 6% better or so than GPT-4 at the time that this test was run. But you can see that's not true of undergraduate level knowledge or of math problem solving, where GPT-4o outperformed Claude 3.5. So this is another issue, right? If you're going to be using a generative AI system, there's a meta question of which system should you use for which problem. And that's not always obvious, particularly with the rapid pace that these things are evolving. Okay. Another challenge that we have with generative AI systems is not just at the level of the training, but also in the way that they can be prompted. The prompt size of a large language model is not infinite. I can include a certain amount of instruction. I can include a large portion of a book inside of a language model's context window, but I oftentimes can't provide all of the content that would be relevant or necessary to answer a given query. I'm sure you've experienced this if you, for example, manage a large code base or have a large document that you want to answer questions about and have experienced issues with ChatGPT or other generative AI systems not being able to answer questions, just simply refusing due to the context window limitations. Okay, so prompt sizes basically are not infinite, and they're getting bigger. As you can see illustrated in this diagram over time, we're at about 10 million tokens for Llama 4 now. 1 million tokens is sort of more common for other AI models. But this is really, it's not enough, right? Just Wikipedia, which is not the whole internet, is 38 billion tokens. So 10 million is pretty small when you compare it to a number like 38 billion. Okay. Another important thing is even if the context window of these LLMs was infinite, so even if I could type in as much as I wanted into the prompt of an LLM, more text doesn't always help. What I'm showing you here on the left-hand side is a graph that was pulled from a paper down here where they took a question and let's call that question, the relevant text was in red, and then they increasingly added irrelevant nonsense, let's say illustrated by the gray text here, and they asked the LLM a question or a series of questions that tested its reasoning abilities. And what they noticed was that across the board, the accuracy of LLMs went down, and we're talking about pretty much all of them went down by adding this irrelevant context. So the point here is that even if the context windows of LLMs get very large, even if we can write as long of a prompt as we could ever dream, adding more might decrease the performance. So that's another limitation that we have of LLMs. And it's these limitations at the way they're trained, the hallucinations that they experience, and the other items that we've discussed that motivated the development of AI agents, which are, in brief, an LLM with some ability to do planning and access to some tooling. And it's the latter two, the planning and the tooling, that helps address many of the deficiencies of the LLMs that we just discussed. Okay, what I'm showing you here, so it's very clear, is the difference between, let's say, an AI workflow that's not agentic, calling just an LLM, like let's say Llama 3 that's on your local machine. You put in a query, the AI takes your query, and it provides a response. That's it. Versus an agentic workflow, okay, where you provide a query, some planning occurs after that, tool use occurs. This could be browsing the web to find references. It could be calling a database to look things up. There's reflecting on the results, given what was in the plan and what was in the query, before finally returning the response to the user. So this second mode, this agentic workflow, as you can see, is a lot more thoughtful than the first one. And actually, it's important to note that many of the systems that we think of as being just LLMs, colloquially, right? So Claude, Gemini, OpenAI's GPT models, they're actually agents. GPT-5, which was released just a few days ago, now pretty much does thinking, which is their code word for making a plan, on almost every query that you ask it that's not phenomenally simple, and does that right out of the box. Oftentimes, as a consequence of that plan, it will make a call to the internet, which is a tool. Okay? So again, easy thing to remember here. An AI agent is an LLM with planning plus some tooling. Some of the common tools which you will encounter as you're developing these systems or reviewing them externally are databases, machine learning and deep learning models, APIs, sometimes humans. These are all tools that the AI agent can interact with so that it can accomplish its purpose. Here's a concrete example of an actual AI agent that was reported in a paper that you see down here. In this case, a user wants to plan a trip, and they've listed some constraints in the trip that they want to plan. So one of the constraints is where they want to go. They want to go to Seattle. From Seattle to Vancouver. They want to go for 3 days. They want to visit at least 2 attractions per day, and they want accommodation for 3 people with a budget of $300. So that's very specific. There's a whole lot of constraints in there. So as opposed to taking this, providing it to a language model, and praying that the answer has no hallucinations, the agentic solution is to first take this text and, actually using an AI LLM, for example, extract some constraints. One of those constraints might be that the daily budget is $300, and you could enumerate a set of these constraints from there. Okay, so now we have a set of these end constraints. A second thing that we'd want to do is have an AI agent take this input and use some tools and some reasoning to generate a potential plan for this person's travel. What are some of the tools we might use? Well, World Wide Web probably, right? We go to Google, we type in, what are some attractions in Vancouver? We type in hotels in Vancouver, and so on. Okay, we use some reasoning to try to figure out whether we've accommodated the constraints before generating a response. Now, these get checked against the constraints that were separately extracted here. And if all constraints are met, fantastic. We move forward. If they're not met, maybe we repeat the process. So this flow is an agentic workflow, an agentic solution to a problem, which you can see is far different from just asking an LLM directly to give you the trip plan from Seattle to Vancouver. So that's an AI agent. What is agentic AI? Well, it's simply when you orchestrate multiple AI agents. So AI agents are LLM, planning, and tooling. Agentic AI is the orchestration of many tools with LLMs, planning, and tooling. I've got an example down here that comes from a Medium post that I pulled. We might have a topic that goes to a research agent, which has tools to search the internet, has some context, has memories, obviously an LLM to reason across this information. After the research is performed by this first agent that maybe has a custom prompt that's really good at doing research, it gets passed to a manager agent who sends this to a writer agent as well as a publisher agent, which exchange information not only among themselves, but also with the researcher agent to synthesize a final response that arrives to a human who, after approving it, publishes the article. Okay? So orchestration of multiple AI agents is agentic AI. What's really impressive about AI agents and agentic AI systems is what they can already accomplish and how much human time they can save, especially in our domain. If you're taking this class, I assume you are either a computer scientist or you're computer science adjacent. And what I'm showing you here on the graph is a timeline. Along X is the years, and along Y is a task duration for a human to complete something. So this is in minutes. You can see from 0 all the way to 24. And the way you read this is that for an average person who's proficient to implement a very simple web server, let's say a Flask application like what we're going to be using in this class, it takes something on the order of, 23 minutes or so to do it. What this is showing you on the right-hand side is that LLMs can now do these tasks that would take a human 24 minutes, basically much faster than 24 minutes, but importantly, completely autonomously with no human input. So if we were to look at this item, finding a fact on the web, let's say we had to find 1,000 facts on the web, that's 1,000 times 12 minutes worth of work that now AI can do effectively at an infinitely lower cost relative to the human labor costs, and with very impressive success rates. All the tasks that you're seeing here, it's reported AI can do it with approximately 80% success rates. Okay? Now, they're not perfect at everything, but they're getting better, right? Here's some examples of other more advanced technical tasks that AI agents can do that take human beings a lot more time. So here's an example of scraping records from a website with anti-bot protection. This is a common kind of thing in a lot of data science workflows. Human being takes between 1 and 2 hours to get this task done, and many AI systems can now do this completely autonomously with success rates at or above 50%. So agents are accomplishing some really incredible technical things, and I only think it's going to get better. This is probably the reason why we have seen an increase in interest in AI agents. So what I'm showing you here on this timeline, starting from November 2022 all the way through 2025, the present, is the interest in these two terms, AI agents and agentic AI. Remember, ChatGPT came out in November 2022. What you see is that after a couple years of using it, almost exactly 2 years, in fact, of GPT coming out, people started to realize all those problems that I enumerated. The 5 or so I spoke about earlier that motivated agents and agentic AI, and you saw an explosion in interest in these 2 topics. So it's a good time to be learning about this if you're in the class. So speaking of learning, how are we going to be approaching the learning regarding AI agents this semester? Okay. Well, we're going to be approaching this as a systems engineering task. Okay. The reason is because while agentic AI does utilize scientific advancements in AI, like there's a lot of science that goes into making LLMs better, making reinforcement learning better, and so on. When people talk about AI agents or agentic AI, it's primarily rooted in engineering paradigms and approaches. So these include goal-oriented design, getting AI systems to achieve very specific objectives, careful planning, defining system capabilities, and ensuring we can operate effectively in a given environment. This is very much an engineering problem. It's important in science, but it's far more important in the engineering context. System integration is another important consideration for agentic AI, taking various components, LLMs, APIs, databases, and other systems. And this integration requires expertise in systems engineering so that you make sure the pieces can interact seamlessly and perform reliably. There's software development that has to take place because if you're going to orchestrate multiple systems, obviously software engineering principles are going to be important. And human-centered design is also critical here because if you want an AI system to ultimately transact with a human being, you have to understand how the human beings are going to interact with the systems and make sure that you're friendly to those common interaction patterns. The final one here is iterative development. So like any engineering project, developing agentic AI involves an iterative process of design, testing, and refinement. That's central to any engineering practice. And so in this course, these sort of 5 pillars inform how we will be structuring the assignments in the class, how we will be doing the assessments in the class, and even the topics that we will be covering in subsequent lectures. In the next video, I'm going to be taking you through in a little bit more detail the syllabus, the course material, and some of the other fine P's and Q's around this class. But I wanted to end with letting you know the guiding philosophy or principle for how we'll be conducting this course. Hopefully it makes sense to you, and I'll see you in the next video.